Hi, Denver Java User Group. My name is Matt Rabel. I'm substituting in for Greg Ostrovich tonight. He was out of town. I don't even know why he's out of town, but he put me in charge, so I'll be doing his normal spiel. Not quite as good. I don't have as much information about the sponsors, but I do have this presentation here, so that should be a start. Let's see if I can make that a little bit bigger. Does it actually get bigger in StreamYard? Nope. Oh, well. Okay. So we're just going to run through this real quick. Schedule tonight. Obviously, we're starting right now, 5:30. This video will be available on YouTube at this URL, though, as long as Jeremy wants it to be. If he tells us to remove it, then it'll go away. But, for now, we're going to do some intros and announcements. And then if you did want to have some of the sponsors' drinks or pizza tonight, well, they didn't actually deliver it to our houses. So tonight, that's up to you. If you want to grab a beer out of your fridge, please do it. Maybe some wine or maybe just, a seltzer or some water. That's all fine. And then at the end, we'll have door prizes, but there won't really be that. It'll be more of a Q&A at the end. What we'll do is in the chat, we'll post a form to enter a raffle. We'll probably give away an IntelliJ IDEA license and maybe something else. Not sure. Haven't done this in a while. So Mike usually hits that up, and that'll be in the comments. So obviously, if you're watching in some playback mode, then no raffle for you, but everyone else gets to do it. So here's some resources if you're not familiar with debug, and there is that raffle link at the bottom there. So if you're watching this, you could just pause right now and go and enter that raffle. But like I said, we'll also put it in the chat. So you can find us on Twitter at djug. We don't have a GitHub handle yet, but we also have a job list sign up. And I'm not sure if this actually exists because look, it's Yahoo Groups, and don't know if that's being used. So if you are using that or have found a job from that piece, please post something in the chat so we know it is working and still being used. So we have a whole slew of sponsors tonight, and some of these sponsors have slides and some don't. So I'll just start going through those. We have Tech Systems, who Courtney Elterman, you can see her email there, will help you get a job in Java if you don't have one. So contact her for that. Some open positions are Java and Angular in Westminster. Nice little town up there. We had UberConf there last year, and a bunch of Java and Spring Boot developers needed, some DevOps, and some data engineers and data scientists. We also have Braden Collip, and I'm pretty sure Braden just got a new job on LinkedIn, so he probably doesn't work at Apex Systems anymore, but Apex Systems is a sponsor, so check out their gigs. Develop Intelligence. If you want to be an instructor or get taught by one, it's a good way to do it. Contact Bob Clary there, and you can visit them on Develop Intelligence as well if you'd like to, work for them. And then if you want to work for Amazon, they have a whole bunch of positions. Just go to amazon.jobs and search for Denver. My company, Okta, is a sponsor, and we just do that because, we love you all, and we think that no one should have to write authentication if they don't have to. So check it out, developer.okta.com. NextGen has some open positions for a mid-level, senior-level Java developer. Contact Dana there. And Agile Learner, Venkat Subramaniam, awesome guy, awesome product here. The old Agile Learner, he does a bunch of videos that you can watch and learn quick and easily. Sponsors JetBrains, IntelliJ. Hopefully you've tried IntelliJ. If you're just using Eclipse and you've never tried IntelliJ, you're so missing out. You should try it. And so they're giving away a free license tonight. And then we have a survey after the talk. So if you liked what you saw, you want more Jeremy, let us know in that survey, or if there's any speakers that you would like to see or any topics that you would like covered. We do have a talk from Sharath from Oracle next month, and he will be discussing Java 17 and stuff. So that's what's coming up. And we'll probably take December off just because it's a busy time of year. So we like to do that. And then from there, we will, resume normal activities next year. So I'll stop sharing and introduce our speaker tonight. So the topic is Java logging deep dive. And I really have to praise Jeremy for this talk because he's one of the first speakers that actually made his own thumbnail and sent it to me. And it's a really good thumbnail. So thanks for doing that, Jeremy. That's awesome. And in Greg Ostrovich style, I would like to read you Justin's bio, so or Jeremy's bio, sorry about that, so you know all about him. Jeremy is a software developer, a consultant at Crafted, a consultancy that utilizes a balanced team model to efficiently deliver the right product for clients. It's a good intro there, Jeremy. Prior to Crafted, Jeremy worked at Pivotal Labs, where he originally became involved with the consulting side of software delivery. Remember, like we used to meet there? Cool place. He has worked in a variety of tech stacks, including .NET, Python, and Unity, and definitely has a soft spot for Java and Spring. Outside of work, you can usually find Jeremy in the mountains, sliding down them in the winter and climbing in the summer. So as I was doing that, I just realized I totally missed Chris from the Boulder Jug. So Jeremy, normally I'd bring you up right now and be like, here's Jeremy, but we're going to give a little time to the Boulder Jug to mention their sponsors. Then we'll bring up Jeremy. So hello there, Boulder.
Hey, thanks very much. So like Denver, we want to thank Tech Systems, James Corboy. We normally meet at Rule 4 Cyber Security and Emerging Technologies. They're last year's Colorado Technology Association Award winner. They also have a large DevOps meetup, and they also have a large Linux meetup. And they're actually, both of those are meeting live. No Fluff, Just Stuff, Jay Zimmerman, World Class Conferences and Training, Agile Developer, Venkat, JetBrains, IntelliJ, and O'Reilly Books. If anybody is interested in a JetBrains license or Agile Developer video training, contact me through the Boulder Java users group, and I'll try to hook you up with that. Thanks very much, Matt.
You are welcome. All right, so now we'll bring up Jeremy here. Hello, Jeremy. How are you this evening?
I'm doing great. Thanks for the introduction, Matt.
All right, so we'll let you take it away, and then I'll pop in with any questions if people have them, or just see you at the end.
Cool. Thanks a lot. Yeah, so thanks to Matt again. Also, thanks to Greg and Chris and Mike, who I met, and Buddy the cat. Can't forget Buddy. Yeah, and thanks for all the attendees and sponsors as well. As Matt said, I'm Jeremy Gustine, software engineer with Crafted Solutions, and yeah, we do consulting with a variety of different tech stacks. We have pretty deep Java knowledge, so if anyone needs anything, let us know. Yeah, as far as my inspiration for this talk, a few years ago, I was working at Pivotal on a greenfield project, and we had some needs for a caching solution. So we were working in Spring Boot, needed to pull in Gemfire, which is like the commercial version of Apache Geode, if anyone's familiar with that. And we also had some like custom logging needs. So we've got, Spring Boot's default Logback implementation in place, changed the little pattern for the logs, started everything up, did some caching stuff, and realized that none of the logs from the Apache Gemfire, from the Gemfire client were like respecting those the logs that were configured for Logback. Just figuring what is going on here. Anyway, came to realize that this particular client library had its own custom proprietary logging implementation in place. And I kind of tried to figure out, all right, this is an interesting scenario. It's a new one for me. How do we deal with this? And this led me down a very, very deep rabbit hole, figuring out how logging works with Java. So yeah, that's the history of what led me to my interest in that. And so now I'll share a lot of that information with you. Just so you're aware, this talk will be mostly looking at the dependency management side of logging in Java. We won't go too deep into appenders and different things like that. We may gloss over the surface, but we'll be doing a lot of looking at build.gradles and stuff like that. So I will go ahead and share my screen. Okay, and hopefully everybody can see this GitHub repository. So yeah, Matt, hopefully you can put this in the channel for everyone to access if they'd like. But this is just a repo with a README that has a lot of information I'll be going over, and then a few projects that we'll be digging into as well. So first things first, I'm just going to go ahead and read over this section just to get a quick overview of the different logging frameworks available in Java. So the first one available is, of course, just the console. So system.out, system.error, just simple logging to standard out and standard error. It's the oldest method of logging with Java. It's been there since the beginning. Logs are always printed to the console, regardless of where the application is running. And in production, standard out was, back in the day, commonly redirected to dev null to reduce logging of sensitive data and unnecessary data. Pros of this approach is there's no dependencies. The cons are there are no extra features, and it's always on. So certainly not very feature rich. because of its lack of features, Log4j was developed. So Log4j introduced the idea of logging levels to mitigate the always-on nature of the console logging. This allowed different environments to choose which logs would be written. In addition, Log4j introduced appenders, which are responsible for outputting logs to a single destination type. So that would be like files, databases, rolling logs, etc. You can write an appender to post to Facebook or what have you. Log4j's development reached the end of life in 2015. So pros, it has log levels, it has enhanced customization, and it's widely used. It was really the standard in the Java world for quite a long time. And cons is it's no longer the newest kid on the block. There's some ones that are more widely used these days, and they're going to be a little bit more performant and flexible. And of course, here's the URL if you want to read over the manual for that. After that came Java Util logging, aka JUL. So Log4j became extremely popular in the Java community, and this gave rise to the development of the standard library, or the inclusion of a logging framework in the standard library, and that was finally introduced in Java 1.4, Java Util.logging. So this logging framework never really caught on due to the limited out-of-box output functionality. So there was only a console and file output appender. Apparently there was not like a rolling log one as far as I'm aware, and things like that. And by that time, Log4j was just so widely used and, frankly superior that this one just never really caught on. Pros of this approach, no dependencies, much like the, just standard console that we went over earlier. So that's pretty nice, but limited out-of-the-box output adapters, poor adoption, and not so great performance. So by the time these were released, now developers started encountering a problem, and that problem was that some developers were using Log4j, some were using JUL, and this problem became, a little bit exacerbated, especially when different library maintainers started including different ones, and that really had an impact on application builders. So yeah, as a result, application developers must configure 2 different logging implementations. That's not very fun. So Commons logging was developed to help mitigate the situation. JCL is a logging facade, much like Slf4j, which we'll go over in just a minute. It was recommended to be used by library authors who desired logging without tying consumers of the library that they're using down to a particular logging implementation. So in other words, the author of library X can use JUL if they'd like, and they don't necessarily have to impose that on the consumer of their own library. JCL relies on class loading trickery to discover the logging framework that is being used at runtime. I'm not exactly sure what all is involved with this algorithm. I've read about it a little bit. It definitely sounds like some black magic that was there. And I think maybe many others felt the same. As a result, this led to unexpected behavior, hard to debug class loading problems, and even memory leaks. So JCL is no longer recommended to use. And definitely check out this Stack Overflow answer right here, talking about some of the history of JCL and some of the complications involved with it. So pros, it was Java's first logging facade that can discover the logging implementation at runtime. The cons are high complexity, hard to debug problems, memory leaks, and just don't use it. Okay, so after that, people certainly saw a need for a facade. We've still got multiple implementations that we have to deal with, but JCL didn't quite crack the problem. So Slf4j was developed. And this was developed by the same guy whose name I will not attempt to pronounce out of respect for him, but the same guy who developed Log4j and also Logback, which we'll go over shortly. Slf4j was designed to serve as a logging facade for Java without the problems of JCL. Slf4j uses static binding rather than JCL's dynamic binding to get around many of JCL's problems. Slf4j log redirection is accomplished through bindings and bridges. We'll go over those a little bit more deeply later on, which are explained in detail below. Slf4j enables you to configure a single logging implementation while your application and libraries may depend on many. So I think really the magic here is rather than using the dynamic binding of JCL that figured everything out at runtime, Slf4j had an early binding mechanism that could accomplish that with far fewer problems. Pros, it has very high adoption. I would say it's pretty much the de facto standard in the Java community at this point. And it supports parameterized logging for increased performance. We may or may not go over that. You'll probably see an example of it. And cons, redirecting logs does incur a small performance penalty. So when I talk about redirecting, just keep that in mind. We'll definitely go over that in detail a little bit later. We're almost to the end of this section, don't worry. So the next one is Logback. Logback is simply a native implementation of the Slf4j API. It was intended to be the successor of Log4j, and the combination of Slf4j and Logback corrects one of Log4j's main problems, which is the coupling of the logging API and implementation. So the fact that you've got the Slf4j API, you can really use other implementations and redirect to that API, and that will allow you some more flexibility. And if you're a library author, it'll allow you flexibility while also not being a burden on library consumers. So pros, it's a native implementation of Slf4j, of the API. It has better performance than Log4j, and it's not quite as performant as Log4j 2, which came out a little bit later. And that is the last of the logging frameworks that we'll talk about, which is Log4j 2. It's the newest of the Java logging frameworks. It was designed with performance in mind and takes advantage of modern Java language features. For example, lambdas can be utilized to accomplish lazy evaluation of log statements. You've got asynchronous logging. It's just quite a bit faster. Cons is it's yet another logging framework. But luckily, the Slf4j facade was really put in place to enable people to use a lot of the advantages of Log4j 2 and still get the flexibility that they need. Okay, so we're going to dive into some code in just a moment here. Okay, and this will probably start off pretty slow. We're definitely looking at the basics here, but I promise it'll get more interesting and maybe even slightly funny or sad, depending on your perspective, in a little while. It'll certainly be interesting, though. If the text isn't the right size or anything, definitely shoot a message and Matt will interrupt me. But first, we will take a look at the first one that I mentioned, just the old school logging, system.out.println. No big surprises here. We've all used this statement many times. So let's go ahead and run that, see what it looks like. Okay, so we've got our logging statement, logging with system.out.println. Nothing fancy. We don't have anything else prepended to the logs like timestamps or log levels or anything like that. It's just what you see is what you get. Before we move on from there, let's take a look at the Build Gradle. As far as dependencies go, there's none. So that's, I guess you could say a cool thing about it. And let's see. Let's go ahead and move on to Log4j. Okay, so now we have a dependency. We've got Log4j here. I'm just adding it to the list, and let's take a look at this. Okay, so I'm sure everyone has seen this line. You've got your logger.getLogger main. This interface is pretty similar among the different logging implementations, whether you're using JUL, Log4j, Log4j2, etc. This line is basically just saying you don't have to have your logback.xml or configuration or whatever, and you can still get the basic configuration there. So let's go ahead and run that. Okay, and there we go. We've got a little bit more information here. For example, we've got the log level, we've got logger.info there. Again, something that I think we've all seen many times. So that was really like one of the bigger, more popular features of Log4j was this log levels here. Let's see. Okay, so now let's move on to Java Util logging. And let's look at the build.gradle. No dependencies. So this is the one that was introduced in Java 1.4. It's built in to the JDK. If you look at the import, it's coming right from where you think it might be. And let's run this. Okay, same kind of thing. We get our info, we get all this other stuff. Great. So again, this is one of those libraries never really caught on. Log4j just really surpassed it in popularity. Okay, let's see. Yeah, and I guess the big benefit here was that you get these extra features like logging level without having to add a dependency. So let's move on from there and take a look at Logback. Okay, so here we've got Logback. Logback Classic, and let's take a look at this. We've got a configuration in here. I'm sure you've seen this before. We've got an appender configure. This is just going to standard out. We have a pattern here. I added in this extra text here for some reason. Maybe not the best example. As a matter of fact, I'll just say load from logback. And in main, we have this logging from logback. So let's go ahead and run that. All right, so we've got this that is coming from our logback configuration in logback.xml. We've got info since we logged at that level. And then, of course, we have the contents of the log. Let's see. Oh, yeah, another thing to mention is, so I mentioned this is logback, but these import statements say org.slf4j. So what exactly is going on there? You might expect to see logback, but the idea is that logback is actually the implementation of the Slf4j API. So those are the imports that you'll see. Okay. And let's do another thing. Let's just go ahead and take a look at the dependencies here. Okay, so when we looked at the build Gradle, we have just this one dependency in here, but what happened when we pulled that in? Well, we pulled in logback, and that has a couple of transitive dependencies. It's got logback core, and then it has Slf4j API. So anytime you pull in this library, you're going to get the Slf4j API, which again, this implements natively. Okay, so now things will get slightly more interesting. Let's take a look at log4j and library with log4j. Or sorry, log4j2 and library with log4j. And let's take a look at the dependencies first. So very simple project. I've got log4j2 pulled in, which you'll notice by this version right here, and just another library. So I've just got a project dependency here. If we take a look at library with log4j, I bet you'll be able to know just by the name what's in there. You'd be right, log4j. This is version 1. So this is maybe the first slightly interesting project here where we've got one with log4j2 that depends on a library with log4j. So what happens there? Can we still run a project that has these two dependencies? Well, of course we can. Let's go ahead and take a look at this code. So we've got the two loggers in here. We've got one from log4j and then one from log4j2 with just slightly different package name structures. Let's go ahead and run this. So we've got logging from log4j and then one from log4j2. And we see them both. We see this one from log4j, this one from log4j2. You'll notice that they're formatted a little bit differently. And the reason is that in this case, we have separate configurations for both of these loggers. We've got our log4j.properties, which has a pattern specified, and then log4j2.xml, which has a different pattern specified. So you can kind of imagine with this example, maybe Java developers back in the day who had dealt with log4j and then Java Util logging rolls around. And they have to deal with applications that have both of these involved. And so the solution used to be, before the introduction of facades, is configuring both of these separately. So, you know, it's certainly doable. It's a little bit of a pain. I would say it becomes maybe a borderline colossal pain when you're pulling in a lot of different libraries, especially if they're not very well behaved and they are relying on different implementations. All right, let's see. So yeah, I guess the point here is that you don't necessarily need a facade like JCL or Slf4j, but it will certainly make your life much easier. And maybe the last thing to show you there is just a quick little example. You can see an example of parameterization here. This is something that was introduced during by Slf4j. And the idea is that you could pass in arguments to these strings. And if your particular logging level was not being logged in a given environment, it would basically prevent the need from, for example, concatenating a bunch of strings together, which over time could be an expensive operation. This is not Slf4j right here, though. This is log4j2. So it just maintains that particular feature, and then you get extra stuff like lazy evaluation with lambdas. Okay, let's see. So yeah, we've talked a little bit about various logging implementations, talked a little bit about JCL as well. So let's dive a little bit more into SLF4j and see what that gives us. Okay, so SLF4j provides a simple API that redirects to your logging implementation of choice. In addition to redirecting calls to the SLF4j API to your choice of logging implementation, SLF4j provides libraries that can redirect logging calls from other implementations to SLF4j. We'll certainly get an illustration of that, don't worry. So for example, a library that uses log4j can have those calls redirected to the SLF4j API, which are then redirected to Logback. Typical projects using SLF4j will include the SLF4j API, a SLF4j binding library, and one or more bridge libraries. If an implementation other than Logback is desired, then the library for the implementation must be included. So an example here is like log4j. There's code for log4j. Getting logged, it might redirect those calls to the SLF4j API. That might go to the implementation, which is actually Logback in this particular example, and then Logback will do the work of logging it out. So let's take a look at some of the binding libraries. The binding on your class path determines which implementation of logging framework SLF4j will redirect to. The binding will determine the final destination of logs. A binding must be present on the class path for SLF4j to use it. Think of the binding as a translator. For example, if SLF4j API and SLF4j Log4j12, man, that is a mouthful, and Log4j are all on the class path, then calls to the SLF4j API will be forwarded to the binding SLF4j Log4j12 in this case, which wraps the Log4j API and forwards the data to Log4j. Okay, so yeah, I know that can be pretty hard to follow, but I promise you we'll have some examples that clear that up. But here are some examples. I think it might be nearly exhaustive. A list of the bindings that you can use. So SLF4j Log4j12. This is basically the binding library for Log4j. So it redirects calls from the SLF4j API to Log4j. And the Log4j dependency must also be present on the class path. SLF4j JDK14 redirects calls to the Java util logging. SLF4j simple redirects all calls to system.error. SLF4j JCL will redirect them to JCL, and the JCL dependency must be present on the class path. Logback Classic is the native implementation of the SLF4j API. So really no redirection occurs, but I kind of think of it as the same way, just to keep it consistent with the others. Basically, it's just the implementation behind the SLF4j API, that's where logs are going to go. And then Log4j SLF4j IMPL, they decided to deviate from the naming convention for some reason, but this redirects calls to Log4j2. So the Log4j2 dependencies must also be present on the class path. Okay, let me see if there's anything else I'd like to mention to you before we go to the next section. Okay. Yeah, maybe the one thing to mention here is that the way the bindings work is the SLF4j API will look for an instance of static logger binder on the class path. And it will look for this from the binding libraries. So it's looking for one of these items from the class path. I'm sure you run into situations where you have maybe multiple classes of the same name all on your class path. And that may be caused by, for example, 2 different versions of a library being included or something like that. And you've run into issues dealing with those class path problems. This is basically the same kind of thing. It's looking for one instance of the static logger binder. And we'll see a little bit of examples later of what happens when there's more than one. Okay, so let's go ahead and talk about the bridges now. And by the way, definitely check out this slf4j.org/legacy link. It has really good pictures that can explain this very well. So the bridge libraries implement the API of the logging framework that they are bridging. As such, they are intended as replacements for the other framework dependencies. Many examples on the internet fail to mention, even the official SLF4j documentation glosses over it, that you must exclude the framework dependency that you intend to bridge. In other words, if log4j over SLF4j is on the class path, then log4j should be excluded. Likewise, if JCL over SLF4j is on the class path, then JCL should be excluded. So basically, what this is describing is, say you've got a class in log4j. Maybe it's at a fully qualified package name of, for example, com.log4j.logger. Basically, the bridge is going to use that same exact package name structure and class name and implement that. But rather than actually doing the logging, it's going to send the logs to SLF4j. So you could think of it as kind of a pretty clever hack where there's another library, kind of like a doppelganger of log4j or JUL or something like that, that looks the same on the outside, but on the inside, it just simply forwards logs to SLF4j. So when you include that on your class path, you got to be sure to get rid of the real one. But the code of that API of the bridge looks good enough that all your code will compile and you'll be good to go. So let's see. Yeah, definitely check out this link. And then this is a pretty important thing to know. It allows Log4j users to migrate existing applications to SLF4j without changing a single line of code, but simply by replacing the Log4j jar or JUL or whatever it is that you're bridging with Log4j over SLF4j as described. To use Log4j over SLF4j in your own application, the first step is to locate and then replace a log4j.jar with Log4j over SLF4j. Note that you still need an SLF4j binding and its dependencies for Log4j over SLF4j to work properly. Okay, so you may have gathered by now that this is slightly complicated. Certainly not hard, but it's a lot of information to know. So yeah, this is as far as I'm aware, exhaustive list of the bridging libraries. So we've got JCL over SLF4j, JUL over SLF4j, Log4j over SLF4j, and then Log4j to SLF4j. So just a slightly different name there. One is for Log4j1, one is for Log4j2. Let's see. The one thing to be aware of is the way I described the bridge libraries working as one kind of being like an imposter of the real one. It's actually not true for JUL, and that is because a library, or basically any code that we implement in Java, cannot have the java.star package structure because that is reserved. So that one uses some extra kind of crazy hack that I don't totally understand. It is described at this link here, but know that there is, in that case, a bit more of a performance penalty to redirecting the JUL logs than there is for the other libraries. Okay, so we went over that. Let's go look at some code again. Okay, and we will look at SLF4j no-op. All right, so we've got SLF4j, just the API here in our dependencies. And in our code, we are importing that, and we're just going to log to it. So let's hit run. And you will see that we don't see this logging statement at all. But what it says is failed to load class org SLF4j impl static logger binder. This is the implementation of that class that I mentioned earlier. Basically, the API is looking for a binding dependency to be on the class path with that package in there. That way it knows where to send the logs. There's nothing there, so it defaults to the no-op logger implementation. So in this case, if you don't include the binding, you're just not going to get any logs. Okay, so next we will look at SLF4j simple. So this one includes the API, and it includes SLF4j simple. So this is the API dependency, and then this is a binding for it. So this will have that static logger binding implementation in here. And this particular one is very simple. It's just going to go ahead and send all logs to standard error. That's just what it's designed to do. Okay, let's see. So we will gradually get more interesting. We're looking at Slf4j Logback and library with JCL. Okay. So this is starting to look slightly more complicated, but we've got the Slf4j API. We've got Logback Classic, which is the binding for Slf4j, and it's the Logback binding. Then we also have a bridge library, JCL over Slf4j. Now, as that README I just showed you a little bit earlier mentioned, because we have the bridge for JCL, we need to make sure that JCL itself is removed from the class path. So that's exactly what this is doing. So anytime you have a bridge for something, go get rid of the real thing. You want to put the imposter in its place. So let's also take a look at this library with JCL. Okay, and as you see, yeah, it's just got JCL on there. And now let's take a look at the code. Okay, so we've got this API using JCL. This is coming from that other project dependency, and it has a really cool named method, do stuff. And what this is doing is logging with an implementation of JCL. Okay. Now back in here, we've got this logger, and this is coming from Slf4j. So according to our code, the way it's written, we have a logging statement from a library that's going to log to JCL, and then our code is going to log to Slf4j. I guess the question is, what do you think will happen at this point? And based on all the information you see in here and what we've gone over, oh, maybe there's one more thing I'll show you. We have this logback configuration. So it says logging via Slf4j. Okay, so that's good to know. Let's go ahead and run that and see what happens. Okay, so we see two logging statements, logging from Java Commons logging. And at the beginning of that statement, it says logging via Slf4j. And then it also says logging from Slf4j logger. So basically what happened is this do stuff method logged out something through the JCL API, but because we put the JCL bridge in place of the real implementation, it got forwarded to Slf4j, which sent it to the log4j implementation. Okay. Let's see. Okay, so let's see what happens if we didn't handle that quite right. So let's say we have a project where we know we want to use logback. So we've got the Slf4j API and logback. And we pull in this library. We don't really pay attention to what's in it. So we don't bother doing any of this work. And this is a very, very common situation. This is exactly what led me down the hole to investigate a lot of this stuff. So think for a moment and make a theory as to what might happen here. Let's go ahead and run that. Okay. And yeah, you probably had this guess. We still get the logs. This one is actually coming from JCL. And then this other one is coming from Slf4j and logback. So in this case, the bridge, the imposter was removed. So this one is still going to be going to the real JCL. And as you see, it's different formatting and things like that. So we could also handle this by configuring JCL properly, but it's just kind of a pain to do that. Let's see. Okay. So at this point, I think we have a pretty good idea of how Slf4j works. But what can go wrong with it? Let's take a look. The answer is a lot. Okay, so let's look at the first gotcha. Be careful that you only include one binding on your class path. If you include more than one, Slf4j will simply pick one and log the following error. Slf4j class path contains multiple Slf4j bindings. It may be possible that you are including a library that includes a binding, so be careful. Yeah, essentially, just as in that case, I pulled in a library here, library with JCL, and it pulled in a transitive dependency of Commons logging. And so that's just one of those things you have to be aware of. Let's see. So what happens when you don't do that? Of course, you get this error here, but let's see what actually happens. Okay, so here we are pulling in Slf4j API and then two bindings. Slf4j simple, and Slf4j log4j 1.2. And let's go ahead and run this. Okay, so now we see a couple of warnings. Class path contains multiple Slf4j bindings, and then it'll show you where those are. We've got the Slf4j simple, Slf4j log4j 1.2, and it sees two versions of the static logger binder class. So the API doesn't really know which one to grab. Basically, what happens is one of them just gets grabbed. So it is just a warning. Your application will still start, but you might just see some strange behavior. So it's one of those things you should pay attention to. As to which one of these it will pick, we should probably think of that mostly as random. It's going to be up to the implementation of the class loader, not something you want to dig into, certainly not behavior defined by the API, so it's nothing you can rely on. So it's just something you really want to be careful of. Okay. So let's take a look at the second gotcha. If a bridge library and the framework that it is bridging are both on the class path simultaneously, then there's a conflict. The Java class loader will resolve the conflict by simply picking one. Which one? Who knows? Yeah, it'll just grab one of the implementations and it'll ignore the other. This can lead to confusion, lost logs, difficult debugging, etc. So again, yeah, if we think of JUL, actually, let's talk about log4j. You've got the actual implementation and then you've got the bridge. As specified earlier, the bridge is an imposter of the API. They have the same exact package structure and names. So the Java class loader has no idea which one to do. It just picks one. So in that case, if it picks the log4j, the real implementation, you could just lose a lot of the bridging functionality, which means you could lose logs entirely or just not get the right format. Yeah, and then if it actually picks the bridge, that could be a good thing for you, but it's just one of those things that's not guaranteed. Okay, now I will not show you an example of this, but I will show you an example of the third gotcha, which is pretty funny. But I'm going to show you an example before we really describe it. Okay, so we've got the Slf4j, log4j bridge and binding. Okay. So code is very, very simple. Pulling in the Slf4j logger factory, grabbing a logger, and we're logging. Okay. So then in here, we have log4j over Slf4j, which is a bridge library. And then we have Slf4j log4j 1.2, which is the binding. So essentially, we have the bridge for log4j and then the binding for log4j. So if you've been theorizing here and paying attention to what the responsibility of the binding and bridge is here, you might have an idea of what's going to happen when I run this. And you might be thinking, no, there's no way that theory could possibly be right because that's insane. You're right if you're thinking that. Let's go ahead and run that. All right, so this just failed. All right, that's weird. Let's take a look at this. Got a big old stack trace. Oh, what happened? Okay, we got an exception stack overflow error. Interesting. Okay, so basically exactly what's going on here is the log4j over Slf4j bridge is redirecting to the Slf4j log4j binding, which is then forwarding it to the bridge, which is then going to the binding, et cetera, until the stack frames pop and then can't handle it anymore, and then we get this error. So kind of an interesting thing. Not something you could imagine that just throwing a couple different dependencies in there could have such a large impact on, but there you go. I did pull in a little bit of an older version of Slf4j in order to make this happen. The newer versions will actually detect this cycle quicker in the process, and it'll basically preempt the Stack Overflow and say, hey, you're about to overflow, and then it'll crash. So still the same result, it's just happens slightly faster. Okay, let's see. So let's go over the third gotcha now. which is if a bridge library and a binding library for the same framework are on the class path simultaneously, then calls to slf4j will result in an infinite loop. For example, if log4j over slf4j and slf4j log4j12 are both on the class path, then calls to log4j will be redirected to slf4j, which will then redirect calls to log4j. So it's exactly what you just saw. Since version 1.5.11 of the slf4j API, it will preempt the inevitable Stack Overflow error and indicate that declare dependencies have caused the problem. So it is kind of a nice error. It'll tell you what you need to do to your dependencies to cause it. Okay, let's see. Let's take a look at the next problem. And this one is a little bit more insidious and realistic, and can definitely cause some headaches for you. So slf4j simple and Hadoop client library. Okay, so let's take a look at the dependencies here. Nothing too crazy. We've got the Hadoop client, slf4j API, and slf4j simple. So we've got the API library, we've got the binding. This particular binding says just send everything to standard error. And then we've just got this random Hadoop client pulled in. Okay, let's take a look at the main file. Nothing crazy here. We've seen this several times in this project already. Just pulling in slf4j, logging with it. So let's run that. Okay, so this is interesting. We do see the log. That's good. But we also see some warnings. Class path contains multiple slf4j bindings. Okay. And then it tells us which one. slf4j simple, that's what we pulled in, and then log4j12. Okay, well, that's weird. We didn't pull that in, so where'd that come from? Well, it probably came from this Hadoop client. Let's go ahead and take a look at those dependencies. Okay, so we've got our dependency tree here. It's fairly long. All right, and at the top, we've got Hadoop. Let's just start combing through those to see what we can find. All right, so we've got log4j in there. Interesting. We've also got slf4j API and slf4j log4j12. So this is interesting. We've got the API. The client library is also including a log4j12 binding, and then it's also got the implementation as well. So this is one of those things that is actually not the greatest behavior from a library, because this is going to put more burden on the consumer to resolve this problem. In addition, we got pretty lucky when we ran this. Let's actually run it one more time. We got lucky in that we still saw some logs, so that's great. But as I said earlier, there's two versions of this static logger binder on the class path. We don't know which one is going to get chosen. It just happened to choose ours in this case, so that's great. But what if it chooses the other one? Well, it's kind of hard to simulate that because it's random, or that's how we should consider it. There is a bit of a trick here where we can do this to kind of simulate the other one being picked. So just to explain this trick, what's going on is I'm adding another instance of the static logger binder to our class path. So now there will be three. And then this one is just going to grab the log4j logger factory and return that. So it's going to use the log4j factory that's included from the Hadoop client. What I'm hoping this will do will simulate log4j getting picked rather than the slf4j simple binding. And the reason this should work is because the class loader will pick code that is in our code base prior to that of libraries. This is just kind of like a class loading trick. It depends on the implementation details of that. So don't rely on it. But this should do the trick for our simulation at least. So let's run that. Okay, we see the same errors. Now we see three of those, as I mentioned we would. Static logger binder, and a third one. And we do not see our logging statement at all. So that's kind of interesting. So if we look here, we see some warnings from log4j. It says no appenders can be found for the logger. Please initialize log4j system properly. So basically what happened here is the class loader chose the Log4j binding implementation, and we do not have a configuration for that. And so therefore Log4j won't do anything. So this is one of the worst problems that can happen when you pull in a library with transitive dependencies on bindings that you're not relying on. You can get very strange behavior like this. And hopefully you wouldn't get all the way to production and see an issue like this. But if so, you're going to be missing out on some logs. It's one of those things, maybe it's not the most critical thing, because I'm sure you'll find it before it gets there, but it can be pretty painful to debug and just figure out what's going on, not to mention tedious. Okay, let's see what is next. Okay, so let's take a look back here. So tips for library authors. Libraries should depend on Slf4j so that the final application consuming those libraries can choose the implementation. The author of Log4j, Slf4j, and Logback makes a compelling case on Stack Overflow. Definitely read this. Even that, though, is not always 100% effective, and that's because of the issue that we just saw. Library authors may want to include an Slf4j binding so that they can test with a logging implementation. Remove the consumer's burden of excluding the implementation dependency by declaring the dependency in such a way that it is not transitively included. So yeah, I guess I didn't necessarily talk about the fix for this situation here, but if I really needed to include the Hadoop client, unfortunately, the binding is in there. There's not much I can do about it. I can email them maybe a message on a GitHub issue and say, hey, can you exclude this? For all I know, they have some sort of esoteric technical reason to include it. But basically what we should be doing here is excluding that from this dependency, and then we wouldn't have that problem at all. But again, it's one of those extra things we have to do. So what this author could do is use compile only on their binding in Gradle. So that would basically allow them to test with their implementation, but when they package it up and send it out, it means that it's not going to get included transitively for me. And then with Maven, you can use provided or optional. There is another pretty cool thing you can use. I haven't tried this myself, but you can use the Maven Enforcer plugin. And this, yeah, you can actually see here. Setting up your logging with Slf4j, how to automate the prevention of mistakes and disappearing log statements. Disappearing log statements is really not a fun issue. So basically, this Maven Enforcer plugin, you can specify certain things that can be excluded. And so, for example, if this Enforcer plugin was included in my project and I pulled in the Hadoop library, this thing would fail to build for me if it got caught in that kind of scenario. I also just realized, I think it got released fairly recently, but there's a similar thing for Gradle, a Gradle Enforcer plugin. So there's certainly tools out there you can use to help make your job a little bit easier. Okay. Okay, so we're getting kind of close to the end. What I will show you next is what to do with Spring and Slf4j. So let's take a look at Spring Boot with default config. By the way, if anyone has any questions, definitely feel free to interrupt me. Okay, so we've got our build Gradle here, and we are just pulling in org spring framework.boot, spring boot starter. So the most basic thing you could pull in. Let's take a look at main. Okay, so yeah, looks just like a Spring Boot application. And we've got the same old logging statement that we've been looking at here. So let's go ahead and run that. Okay, cool. We see it. So that's fantastic. Let's go ahead and see what we're really including when we pull in this dependency, because it's usually more than it appears. Okay, let's see. Okay, so when we pull in this one dependency, of course, we're getting quite a bit more than that. But the real important thing to be aware of, for our purposes of this talk anyway, is Spring Boot starter logging. And this is going to include Logback Classic, which will transitively include Logback Core and the Slf4j API. So by default with Spring Boot 2 Plus, it's going to use the Slf4j API and the Logback implementation. In addition to that, it will also include a couple of bridges, Log4j to Slf4j and JUL to Slf4j2. So yeah, this is interesting. I've actually read some recommendations that says if you're using Slf4j in a large project and you're pulling in a lot of dependencies, you might as well just include all of the bridges because then you're just ready to go. Then you can pull in other dependencies that might have dependencies on those, and you should be set. And there's really no penalty for that. You just might be including stuff that you're not necessarily going to use. So yeah, you can do that if you want, or just be kind of diligent at being aware of what's getting pulled in. Let's see. Okay, so now let's take a look at this. We're going to look at Spring Boot and pulling in a library with JCL. Okay, so we're pulling this in and pulling in the library with JCL. This is the same one we saw a little bit earlier. And what we need to do here is go ahead and exclude this. So let's run this. Oh yeah, and then we've got our Logback implementation here, or sorry, configuration. And same thing that you saw earlier, we're going to execute this do stuff method, which comes from that library, which relies on JCL. And then we also have another statement, and that is going to be coming from Slf4j. So let's run that. Okay, and we see our logging statements. Logging from Log4j via Slf4j logger and logging from Java Commons logging. And this statement is prepended with logging from Logback. So that's great. Yeah, that's because we're excluding the actual implementation here, and we don't actually have to include the bridge in addition to this because the bridge is already a transitive dependency here. So that's great. We're all set there. All right, now the last thing I have to show you is Spring Boot with Log4j2 and what to do there. Okay. So yeah, this is one of those things where for anyone who's worked with Spring Boot, you're probably going to pull in a lot of starter projects. And if you want to use Log4j2, you certainly can. There is a starter for that as well. You have to do one of two things in addition to pulling this in. You need to exclude Spring Boot starter logging from each of your starters that you're pulling in. And that ensures that the Logback implementation is not getting pulled in. Or you can just include this in your build Gradle. And that means that you don't have to do this everywhere, which, just could get kind of ugly and repetitive with the more of those that you pull in. So it's pretty straightforward. And then you can get to logging. So we've got our Log4j2 XML. That's great. We've got our main, and we're just going to run this on startup. So let me go ahead and run that. And so here we are logging directly to the Slf4j API and then to Log4j2, but they should end up in the same place. Oh, well, that's not intended. Let's try that one more time. Okay, there you go. Logging using Slf4j API and Log4j2, and everything is prepended with that. So yeah, that's about it. Yeah, as you can see, there's a lot of kind of details to be aware of with this. Once you figure out kind of the relationship between bindings and bridges, then you should be able to debug any of the crazy issues you might encounter and probably will encounter when you start pulling in badly behaved libraries. So yeah, that's all I have for you. If anyone has any questions, definitely let me know. Otherwise, I'll toss it over to Matt.
Yeah, so I have some questions because, I found it quite fascinating and some good stuff in there. So I also noticed you were using Java 8 for everything. I don't know if that was on purpose or just when you created them with Gradle that it said source compatibility 1.8. Is there anything that's changed for like Java 17 since that came out a couple weeks ago?
That
you know
is
of?
a good question. Not that I'm aware of. I have to admit, I haven't been doing Java stuff on my most recent projects for a while. So that's a good question. Yeah, I don't really have the answer to that.
Okay. We have a comment from Maximiliano. I'm not going to try your last name. Hopefully I got the first name right. He said that was really good. So
Cool.
enjoyed
Thanks
it.
a lot.
We also have a question here from Lost Hope Found. Not sure about that username, but thoughts or advice on tools like Elk and Splunk?
Well, let's see. I mean, I think that's one of those things where if you've got like a log aggregator or something like that, then it certainly makes sense to have like a consistent logging pattern that's getting output. I've been on projects where we were doing a lot of parsing with stuff on Splunk with our logs, really wanted to make sure it's consistent. So we've got the same kind of configuration being shared among projects and things like that. And that's when it becomes especially important to make sure that everything in that project is using the same pattern. And that's really where all those bindings and bridges can come in to help you out.
Cool. Another comment. Great presentation. Lots of good info there. And then I have some of my own questions. Any logging horror stories that you have or success stories? I like both failure and success.
I think the one that I mentioned earlier with the Gemfire project, I don't know if I'd go as far as calling it a horror story. Luckily, we saw it kind of early, and it kind of seems that even with all these bridges and stuff, this was a unique case where they had their own proprietary implementation. Gemfire is like this little caching infrastructure, and really what we ended up doing in that case, because the logs were very important to us, is we switched over to Redis. Something that had a nicer client where we could handle this kind of problem. So that's the closest I'd go to horror. Other than that, I think it's been cool to encounter some of these issues in the wild and just be able to, slot in the right bridge adapter, exclude the right kind of thing, and stuff just magically works. So that's kind of fun to see.
All right. I remember back in the day, like just using Log4j and thinking it was the end all be all, right? And then other libraries you use something else and you're like, no. But yeah, the bridging and Slf4j is pretty awesome.
Yeah, it really is.
So build tools, Maven or Gradle. I think we saw you're a Gradle fan. Is that true?
I think that's true. Yeah. I like the fact that it's its own little groovy language you can do what you want with. I like the flexibility of it, but that being said, I also like the just copying scripts from Maven somewhere and just plugging it in here. That's pretty cool too. So yeah, I've used both quite a bit.
And do you know what logging they use?
Ooh,
Like
that's a
for
good
Gradle?
question. I don't know.
Because I don't know. Yeah, I'm just curious if you knew.
No, I have no idea at all. It is interesting though. That's actually something I was thinking about earlier when I was running some of these projects, is you still get warnings, log messages and stuff like that before your application really gets kicked off. I don't really know exactly how those are working, but they don't respect the patterns of like logback or something, for example. So it's definitely a different system.
Right. And then I saw a command you ran to get a dependencies dependency. Like you
Yeah.
might have to share your screen again to show that, but that was pretty slick. Something I could use, I think.
Yeah, give me just a second here.
Because there's like just a Gradle dependencies command, right?
There is, yes.
But you're actually saying for this specific dependency.
Yeah, exactly. So this, this is kind of a big project with a whole bunch of sub projects in it. So yeah, just
Right.
Gradle, name of the project, and then dependencies. And then I throw on the configuration flag just to make it a little bit easier to read.
So that's kind of maybe what I was missing. So if you were in the sub project, you wouldn't need the project prefix. You'd just say Gradle Dependencies configuration compile or runtime or test or whatever.
Exactly. And that configuration thing is optional. You could exclude that and see the different sets. You can see test runtime and
Right.
all that kind of stuff. So.
No, I certainly use dependencies a lot. I use dependency, :tree for Maven, right, to do something similar. And a lot of grepping to figure out if that library that I'm trying to get rid of is still in there,
Oh yeah, that can be pretty tough to parse through for sure.
All right. Another comment from Steven. Really useful presentation. Thank you. Part of the reason I like to show you these is because it's way different when you're doing the virtual presentations, right? Like if you're doing them in person, someone comes up to you and says, nice presentation. I really liked it. So I feel it's important to let you know that people really dug it. And so now the final question that I have, what's your favorite logging framework or option?
I'm not too opinionated on that. I think I typically stick with Logback, mostly because I use Spring quite a bit. I haven't tried like the Quarkus or Micronaut or anything like that. That might change my opinion. But since that's the default with there, I tend to stick with that. But if you are doing a whole lot of logging, I might actually switch over to Log4j too, just so you get some of that extra performance functionality.
Right. So yeah, I would agree with you there. I've had a similar conundrum, right, where I just stopped caring about logging like 5 years ago because I started using Spring Boot so much. But yeah, I could certainly see that the other ones, might be a good option as well. So
yeah,
that's great. So I'll bring up Buddy the cat here and see if he has any questions. Buddy, you still there?
So that was really awesome. Thank you, Jeremy.
Cool. Thank you. Is that Buddy talking or is that Chris talking?
It's Buddy's guardian, Chris.
Okay, cool.
So Chris told us something kind of funny before this whole meetup. I'd like to share it with the audience, and that is that, he works from home all the time, and this is the only Zoom call that he really likes to come into and enjoy. So, good community here. He feels the vibes from everyone. So totally. I will go ahead and thank you for your time, Jeremy. I hope you have a wonderful evening. You as well, Chris. And I will shut this down, and we'll see y'all next month where we get to have Sharath from Oracle come in and talk all about Java 17. So have a great night, y'all.
Thanks a lot, everybody.
That was great. Thank you.